Okay, let's start. So we have to discuss therefore what is the relationship of our course to structural design. The structural design with prerequisite structural theory, wherein we talk about the thought on the principles, methods, on how to analyze the structural elements. So, upon knowing the structural theory, we will now apply the theories and methods in order to solve this problem, actual problem. What we shown you, the buildings, the different components, right, in our previous video. So we will talk about the design of the structure. Okay? So there are two major words here. Design and structure. What do you mean by design and what do you mean by structure? So first, design. Design is actually the application of all the engineering principles so that we can produce a product. Produce meaning make those principles into reality, right? That is what we mean by design. Okay? In particular, when we use the word design in this course, specifically, we are talking about analysis and design. Right? Like we are talking about two things. When we say design, it means design and analysis, right? So, this is actually structural analysis and structural design. When you say design, we are talking structural analysis, structural design. It is different, for example, industrial engineering design. They are not going to talk about structural analysis. They will not talk about structural design because that is industrial engineering design. Okay? Electrical engineering design, they will not talk about structural design. Okay? That is the difference. Okay? So therefore, specifically, when we say design, we are just talking about structural analysis and structural design. What are those? Structural analysis, when we say structural analysis, we are going to confirm, we are going to determine if the structure can withstand a particular set of load. Okay? When we say how to determine the structure if it can withstand a particular load, meaning we are given the actual dimension of the structure. We are given dimension, for example, just imagine this is a long rod, long steel rod, for example, steel rod. Okay. So then this steel rod is going to be used as supporting beam in a simple structure, right? So we are given the dimension, meaning we are given the length of the rod, we are given the cross-section of the rod or the diameter in this particular example because this is circular. So we have diameter and length. So that is what we mean by dimension, right? Very simple meaning, no? However, when we say analysis, is this particular dimension can withstand, for example, 3 kilos of load when utilized as beam? That is what we mean by analysis. We would like to be able to confirm if yes or no, can this structure withstand 3 kilos of load if utilized as beam with specific diameter. For example, specifically, what is the diameter? About 20 mm. So about the length is about 12 centimeter to 12 centimeter, not 12 inches, 12 centimeter, and then 20 mm diameter. Can this beam withstand 3 kilos of load? We will use structural theory, their principle, computation method, in order to finally decide, finally answer the question, yes or no. Yes, it can. No, it cannot. So that is what we mean by analysis. Okay? Specific, very specific definition of analysis. Now, what do we mean? Therefore, we are given dimension and we want to evaluate the structure. Right? We are evaluating if it can or it cannot. Right? Now, design. What do we mean by design? We are not given the dimension. We are the one who will determine the dimension. That is design. Okay? That is structural design. What we are given is the load. We are being asked, design a simple beam structure that could withstand 3 kilos using our computational ability coming out from structural theory, methods that we learn, compute. Then finally we can determine through computation 20 mm can withstand 3 kilos. We determine that 3 mm can withstand. So that is what we mean. We are given the load, given loading, given the load, we are able to determine the dimension. Are we clear? Are we clear between these two when we say analysis and design? Therefore, analysis and design, therefore, they have opposite meaning. One is going here and the other is going here. No? So, we are already given dimension. We are just going to evaluate if the load, if 3 kilos can be used in that structure. We are given 3 kilos, we would like to find the dimension. Okay? Well, no? Take note. That is the specific meaning of the word analysis and design. I think this is the first time you ever have the certainty of what do we mean by the word analysis and design. Okay? Very specific, no? Okay? Because analysis and design, very broad. Everybody will use the word analysis and design. Okay? But when we are talking about the structure, that is what we mean. Okay? When we are talking about structure, therefore, what do we mean by structure? So, structure is anything, objects, anything that performs a specific purpose of supporting a load. That is the specific purpose of a structure. It supports some load. To support load. Okay? We say that is the structure, a building structure, because it supports load. What kind of load? Dead load, live load. Those are kind of load. Later on, we will show you how to react if the loads are not really dead load, live load, or environmental load. We have other types of load. For example, earthquake load. For example, wind load. Okay? So that is what we mean by structure. So anything. So it could be what? It could be example of structure. It could be building. Okay? It could be road, highway, bridge. It could be a dam. It could be tower. They are specifically designed. Okay? The structures are specifically designed for that purpose. To support a load. Okay? So those parts, those components that do not specifically function to support the load, they are what we call non-structural components. There are what we call walls. Walls is not designed to support the load. They are not structural components. Okay? So, there are so many things. For example, windows, doors. They are necessity in a room. They must be there, but it is not structural. Right? Those are building components. Right? Or in some discipline, in architecture, they are called architectural components. So, I will not usually use that word. I will use building design. I am a civil engineer, not an architect. Okay? So, architectural design, they are called architectural components. Okay? So, anyway, there are so many things that supports load. Okay? Building. How about road, highway? What kind of loads they support? Road, they support the transportation vehicles, right? Automobiles, cars, trucks, right? Railroad is also a structure because they support the train that going on top of it. Okay? So railroad. Right? So there are so many things that you can think of. So therefore, the application of structural design, which is under civil engineering, is very much good in nature. Okay? Any other example of structural or structure? These are structure. Okay? Plug poles. They are structured. Right? Electric poles. They are structured. Right? Poles. Right? Plug poles. Structured. Poles. Plug poles or electric poles. They are structured. Right? What else can we think of as an example of structure? Power plant. The power plant, it is a plant that do not bear fruit and leaves. Power plant. Kailangan ba diligin natin ng power plant? Hindi naman. Hindi naman dinidilig yung power plant. So, power plant, so meaning to say, it produces power. What do we mean by power plant? It produces power. It is a plant that produces power. Vegetable plant produces food or flower. No? So, power plant produces power. And it is not a structure in itself, but it is composed of structure. Because power plants have buildings. I think I have yet to see a power plant without building. Power plants have buildings. Actually, they have a dam. For example, hydro, electric power plant. They have a dam. Okay? They have a dam. And engineering quarters. There is an engineering quarter for the management and control and operation of the power plant. Right? There are so many working staff with engineers, technicians, okay, in a power plant. So we have what? Building. Right? The power plant is also, so meaning today, what I'm saying is power plant is very big aggregate of different structures. We have road inside the power plant. Sometimes you have even highway inside the power plant if the power plant is so big. Okay? So, meaning to say, these are the smaller specific sample, power plant is a big sample, right? Big sample, because it involves so many structure design. And there are, if that power plant is electric power plant, we have tower for electric distribution lines, right? Right, so that's what we mean by that. And if that power plant is on the forested area, they may have their own railroad. They have their own railroad. It's short, like the one in DOST. They have their own LRT, but very short, and for, not for traveling, but to show, for demonstration purposes, right? For demonstration purposes. Yeah. About what? 1 kilometer or less than 1 kilometer, no? Very short, no? Very short railroad. That is LRT, right? If you say DOST, so DOST is again a very broad example of structure. So there are plenty of smaller structure inside. There are plenty of buildings. There are plenty of roads, highways. The DOST is very large. That's why there are what you call highway, meaning more than 2 lanes, no? There are roads that more than 2 lanes inside DOST compound. Okay? So we have a bridge inside DOST. I think it's small bridge, no? Small. Even the bridge only for people, we call that bridge already, right? We also call that bridge for people. Just like in Bigotan, we have the bridge for people, that is overpass, okay? Right? So that is also needing and structural design. It needs structural design. One time, last week, there are viral news wherein in some parts of Quezon City, there are two overpass that when they are using the overpass vibrates. While they are using the overpass, it vibrates. And it became viral because, of course, the common people would be afraid to use it. They are thinking it is unsafe. They are thinking it's unsafe. Of course, when the structure is moving, will you feel safe? No, of course. I am an engineer, but I will not go there. No? I would not subject myself to that kind of fear. Fear of what? Fear of collapsing. It would collapse, really. It would collapse. Because the structure is, because the structure is not designed to move. When you are civil engineer and your structure is moving, you should shift to mechanical engineering. No? You design a building here, then after 1 year, it moved to the other side of the road. You might need to shift to mechanical engineering. No? So also, mechanical engineering has the same set of studies, the same with civil engineering, but they are focused on structures which are moving. Like, what are the structures that are moving? Not the railroad, but the bus, the train buses. That is specifically called train buses, right? Right? Not the highway road, but they are designing cars, buses, no? Motorcycles. So that is the relationship. We are all doing the same thing, but for a very different purpose. Right? Right? Now, so they can also design the tower, poles, mechanical development. So they can also design this thing, particularly tower, because towers usually made up of pure steel. So when the structure has a concrete component, that is more on civil engineering. Mechanical engineers do not design concrete. Mechanical engineers usually steel, like what you say, train, bus, car, steel. Okay? Steel component. So, if the question is steel design, mechanical engineers are for specialized for different types of steel. Okay? Do we follow? Okay? These are some lists. So, there are so many things that we can think of, but I cannot in the moment. That's why I put ETC to show I am intelligent, but I'm not. Right? Is the way they use. That's why they invented ETC. Okay. To show they know more, but actually that is the stuff. That's their knowledge. No? Okay. Anyway, therefore, we already specifically define what we mean by design, structure, therefore, what we mean by structural design. So, structural design, this subject is actually composed of one, concrete. The whole structural design topic is concrete. Then we have steel and number 3, wood. Okay. These are the major structural design. When we are talking about civil engineering, we are talking about civil engineering. Right? When we are talking about mechanical engineering, we are talking about different things. Right? When I talk about electrical engineering, I will show you different things. Right? But civil engineering, these are the 3 major. Okay? So, because these are the major materials used for civil engineering. So, concrete design, concrete structural design, steel structural design, wood, and wood is actually, we call it timber design. I don't know why, but in the Philippines, only in the Philippines, right, take note, only in the Philippines, around the world, they are so interested in timber design right now. Only in the Philippines, they scrap the subject wood or timber design. They, meaning, civil engineers in the Philippines do not study timber design right now. On our time, we have the subject timber design. K-12 curriculum, they scrap the timber design for civil engineering. I don't know why. Because if you use Google, in Japan, US, and Europe, which are developed countries, they are so much interested, so many projects about timber design. I don't know what is wrong in the Philippines. Okay? So, therefore, when I say that, our course will only deal with these 2. So, as you said, you will learn from me, and you also will learn from me. Because we do not have this in our, throughout the Philippines, not only in our school, throughout the Philippines. Right? Throughout the Philippines, this is okay? So, if you are given the problem of creating a structure using wood as a material, then you cannot do it because you do not have the background. Okay? Okay? Because wood can be a tower, can be a pole, okay? Can be a bridge, and can be a building. Okay? Okay? I cannot say wood becoming a road or a highway, but it is also a component for railroad. There are very heavy wooden components along the railroad instead of concrete. But if you look at the LRT, they are using concrete by the cross structure that they are concrete. But on the old train railway, they are using wood. Okay? So this one cannot be wood. This one cannot be wood. Done. But there are many things that you can design a structure using wood. I don't know what they are thinking, the Philippines. These are recommendations by Filipino engineers who are expert on structural. That's why, you know, when they say they are expert in structural, why? You do not recommend timber design. I would like some of the influential public figures to know this video for you. This is my reaction to that law, right? Jet regulation. Why we do not study timber right now? Right? What is the reason? They are actually, we have a new timber code in the United States. We have new. Why they are studying and making the code? What do you mean by code? These are the design document. Codes are design documents for engineers in order to implement this design philosophy, right? They are doing it. Everybody, you have your Google. You can Google timber design. I am challenging those experts in the Philippines. You are recommended to scrap timber design. What is your reason? Right? Okay, so let's continue. Ano mga oras na natin? Break time.
10:46.
Break time, hindi ka nagsasabi. Okay, see you next video.